In this lecture, we are going to discuss about wastewater engineering. So, before going to discuss about the fundamentals of wastewater engineering, in GATE examination, wastewater engineering has equal weightage with the water supply engineering. So, try to concentrate more on wastewater engineering also. Okay. So nowadays, urbanization has encouraged the migration of people from villages to the urban areas. This has given rise to a number of environmental problems such as water supply with a desirable quality and quantity, wastewater generation and its collection, treatment and disposal. Like these environmental problems have raised in urban areas for domestic and industrial uses. The source of water is generally reservoir, river, lake and wells. Out of this total water supplied, generally 60 to 80% contributes as a wastewater. In most of the cities, wastewater is let out partially treated or untreated, and it either percolates into the ground and it contaminates the groundwater, which is discharged into the natural drainage system, causing pollution in downstream water bodies. The importance of water quality as a factor constraining water use has often gone unacknowledged in the analysis of water scarcity. Okay, water scarcity is function not only of volumetric supply but also of quantity sufficient to meet the demand. So let's start our lecture. Wastewater engineering. What is wastewater treatment? The process of removing contaminants from wastewater, both runoff and domestic. See, in the previous lectures, we discussed about water supply engineering. Okay, in water supply engineering, we discussed that generally we are having two things. One is the source, another one is the consumers. Here, source, here, consumers. So, source that may be reservoir, a river, or lake, and again consumers nothing but the people. So here there is a lot of process. First, the water will be collected in one place like reservoir and stored, and again we'll be having the treatment of the water. Again we'll having the distribution of water. Finally we'll reach to the consumers, right? After reaching the consumers, again this water we use for the purpose of domestic bathing, cooking and drinking. Again these water has been reached to the south. But the thing is that these used water is nothing but the waste water is having organic matter. So organic matter it consumes, generally organic matter is having the more carbon content, right? More carbon content means it leads to the microorganisms. So wastewater treatment is necessary before coming to the again source. These things we have to keep in mind while discussing about the wastewater treatment. That's what wastewater treatment is, the process of removing contaminants from wastewater, both runoff and domestic. Here contaminants means nothing but the organic matter. Organic matter it consists of the more carbon content that leads to the microorganism. So that's what we need to understand here in this slide. Okay, coming to the next slide. Objectives of the wastewater engineering: to drain the wastewater from the community. See, to drain the wastewater from the community as quickly as possible for safe disposal of wastewater meeting disposal standards. It is very necessary that the community should be safe. That means we have to drain the wastewater from the community as quickly as possible. Okay. Second thing, protect the community from the diseases. I told you that wastewater is having the organisms that leads to microorganisms. So microorganisms will having the more carbon content that is creates the diseases. So protect the community from disease is one of the objective of the wastewater engineering. Another one is the to make the wastewater fit to dispose. I told you in the previous slide there is a two things. One is the source of water, again to the consumers is the final one. In this process, again the cycle will be run. We have to make the wastewater fit to dispose in the form of the groundwater, or again reuse the water. Okay, generally the wastewater is having 99.9% water plus 0.1% solids. So this is the main thing. Wastewater is nothing but a 99.9% water plus 0.1% is the solids. These solids nothing but the organic matter. Okay. So if you try to look at the objectives again, first thing is the main thing objective is nothing but to protect the environment. Environment in the self is water bodies. Water bodies like rivers, lakes, or groundwater reservoir, everything from the human activities. That is the main objective of the wastewater engineering. Okay, so coming to the next slide, where does this wastewater come from? I told you that generally these wastewater come from in residential areas. It will come from kitchen or bathroom, whereas in commercial institution means like schools or shopping malls. This comes under the commercial institution. Another one is the industrial institution. Usually require specialized treatment process. So these are the main sources of the wastewater. Okay. So residential area will be having the main kitchen, bathroom. These for the cooking purpose. These for the bathing purpose. Domestic activities, and commercial means schools or shopping malls, complexes. Everything comes under the commercial. For industrial, we need separate specialization treatment process. So let me discuss about the basic terminology that is used in wastewater engineering. So in further classes also, I will not repeat these terminology. Okay, so these the basic terminology you need to understand for upcoming lectures. The first one is the sullage or sullage. We say sullage. We say generally less offensive liquid liquid wastewater produced by the community is called sewage. Example: wastewater coming from bathroom, kitchen, sinks, wash basins, floor washings, rainwater or stormwater, etc. So generally the less offensive liquid wastewater produced by the community. I told you that generally domestic purpose like bathing, so the wastewater coming. Again for cooking purpose in the kitchen the wastewater coming, and for hand wash purpose from the wash basins. These are nothing but the sewage, that is a less offensive liquid wastewater produced by the community. This is nothing but the sewage. One thing you need to understand here. Coming to the sewage, it indicates the liquid waste water produced by the community. It is The liquid wastewater produced by the community. It is whole in nature due to the presence of organic waste. It is domestic industrial wastewater. That means sewage plus toilet waste plus industrial wastewater. It is also called as a dry weather flow. Here you need to understand that difference between the sewage and the sewage. Here sewage means only the wastewater coming, the most only water coming from the bathroom or kitchen or wash basins or the rainwater or stormwater. But sewage means water plus organic matter. I told you that organic waste means that may be solids and semi-solids. In it is domestical in the institutional wastewater, sewage plus toilet waste plus industrial wastewater. These three terminology here. Sewage means water from bathrooms or kitchens plus toilet waste plus industrial wastewater. These three things is called as a dry weather flow. Very important. Dry weather flow is nothing but the sewage, that is the wastewater from wash basins or bathroom, plus toilet waste plus industrial wastewater. So these about the sewage and sewage. So coming to the storm water drainage or drainage. So the runoff resulting from the rainstorms, from roads, building roofs, and other catchment areas is called storm drainage or simply drainage. It is less foul than sewage. It is also called as a wet weather flow. Okay. In the previous slide, we discussed about the dry weather flow. Dry weather flow means sewage, that is wastewater from bathrooms or kitchens, plus toilet waste, plus industrial. These three call nothing but the sewage. Here drainage. Drainage means it is resulting from the building roofs and other catchments in the form of the water. That is nothing but the drainage. Next, coming to the subsoil water. Subsoil water, it indicates the groundwater which finds entry into the sewers through leaks. Generally, this subsoil water, nothing but the groundwater. Okay. Next, night soil. Night soil means it indicates the human waste or excreta. Here, excreta is nothing but the waste coming from our humans. Okay. Next, this is the one important. Dry weather flow is generally 1 by 20 to 1 by 25th of maximum flow during monsoon. Okay. What is meant by sewer? Sewer is very important. Sewer is a pipe or a conduit carrying sewage. The term sewage indicates sewage plus toilet waste plus industrial. Okay. Sewerage system. Sewerage system means a network of sewer pipes laid in order to carry the sewage from individual homes to the sewage treatment plant is called sewerage. So try to understand here. Sewage is the liquid wastewater from the community. Okay. Sewage means sewage plus toilet waste plus industrial wastewater. Okay. Next, storm water or drainage. I told you that drainage means the rainstorms from roads or building roofs or catchment areas. Subsoil water means it is the groundwater which is coming into the sewers. Night soil means human waste or excreta. Sewer. Sewer is a pipe or a conduit carrying sewage. Sewerage carrying system, a network of sewer pipes. Okay, that's nothing but the sewer system. Now we'll discuss about the components of a sewerage system. Okay, the first one is the house sewer. I told you that sewer is a pipe or conduit carrying sewage. So sewage is a liquid wastewater produced by the community, right? So house sewer pipe carrying sewage from a building to the point of its immediate disposal. Simply, house sewer is a short length of pipe between the intercepting trap and the municipal sewer, house sewer. So house sewer is nothing but a pipe between the intercepting trap and municipal sewer. Okay. Next, coming to the lateral sewers. So lateral sewers, the sewer which sewer means a pipe carrying sewage. Okay, a sewer which receives the discharge from house sewer. Okay, understanding everyone here. House sewer means a pipe between the intercepting trap and the municipal sewer. Okay, lateral sewer means a sewer which receives the discharge from house sewer. Okay, this is the thing you need to understand here. Next, branch sewer or sub means, so it is branch sewer or submain means a sewer which receives the discharge from individual houses. Okay, this is from individual houses. Understanding everyone here? This is from house sewer. Lateral sewer means from house sewer. Okay. Next, coming to the fourth one, trunk sewers or main sewers. So trunk sewers means it is a sewer carries sewage from branch sewers. That means it carries a sewer from branch sewers. Okay, that is the main or trunk sewers. The trunk sewers that carry from branch sewers. Outfall sewer, the sewer which transports sewage to the point of treatment and from the plant to point of disposal. Okay, that is nothing but the outfall sewer. Next, inlets or catch basins. Inlets or catch basins in the sewers which carry the drainage discharge either solely or in combination with sewage. Inlets called catch basins. Okay, catch basins are provided to permit entrance of storm water from street gutters. Okay, so another one is the manholes. Manholes provided in every sewer pipe at suitable intervals to facilitate their cleaning and inspection. Okay, everyone try to understand here. First one is the house sewer. House sewer means it is a short length of pipe between the intercepting trap and the municipal sewer. Another one is a lateral sewer, the sewer which receives the discharge from the house sewer. And branch sewer, branch sewer receives the discharge from individual houses. Trunk sewer that receives sewer from branch sewer. Outfall sewer, the sewer which transports sewage to the point of treatment. Okay. Another one is the inlets or catch basins which carry drain and discharge either solely or in combination with sewage inlets. Okay. So these are all the components of a sewerage system. Another one is the manholes. Manholes are provided in every sewer pipe at suitable intervals to facilitate their cleaning and inspection. So according to Indian standard IS 47 4764 1973, the tolerance limits for sewage effluents discharged into land surface waters. So this Indian standard speaks about the tolerance limits for sewage effluents discharged into inland surface waters. Okay, inland surface waters, inland surface waters. Okay, another one is the IS Indian Standard Code 2490 2490 1974 It discuss about the tolerance limit for industrial effluents discharged into inland surface waters. So it discuss about here Indian Standard 4764 1973 discuss about the sewage effluents discharged into inland surface waters, and IS 2490 1974 discuss about the industrial effluents, that is industrial effluents discharged into inland surface waters. So this is the two Indian Standard Code provisions that discuss about the tolerance limits for sewage effluents and industrial effluents. Okay, next, coming to the systems of sanitation. Okay, so generally the conveyance system, we'll discuss first about that. Generally, we are having the two types of the uh, systems of sanitation. One is the first one is the conveyance system or dry system. Another one is the water carrier system or wet system. First, we'll discuss about the dry system. So generally, the dry system is a old and outdated. Okay, separate collection and disposal of liquid wastes and solid wastes by the sweepers. Generally, the dry system is very old. There is a separate collection of dry and wet, the separate collection and disposal of liquid wastes and solid wastes to the sweepers. Okay. Coming to that, what are the drawbacks means unhygienic and insanitary conditions, nuisance during transportation of human excreta, disruption in working of system due to labor or sweepers problem, risk of outbreak of epidemic, pollution of water, larger requirement of land for disposal of refuse, humiliation, and social injustice. So conveyance system is a dry system is old and outdated. There is a separate collection and disposal of liquid wastes and solid wastes by the sweepers. This thing we need to understand here. These are the drawbacks of conveyance system. Next, coming to the second one, water carrier system or wet system. Generally, it is collected in sewers. Sewer means a pipe or a conduit. High initial cost and large quantity of water is required. Decent and efficient system used in modern days. So dry system is outdated and wet system is a modern days we are using here. Okay. Comparing with water carrier system is the best one compared to the conservancy system. Okay. Next, we'll discuss about the types of water carried systems or wet systems. So initially I told you that generally there are two systems for the dry system and wet system. Dry system is outdated one. There is a separate for disposal of solid and liquid waste. So wet system is efficient one. So coming to that, there are three types of water carriage systems. Again, it is classified into one is the combined system, separate system. Another one is the partially separate system. Okay. First, we'll discuss about the combined system. Combined system, when the what drainage is taken along with sewage, it is called a combined system. Okay. It handles both dry weather flow and wet weather flow. I tell you that dry weather flow is nothing but the sullage. Sullage means the wastewater coming from bathrooms or kitchen or anything, plus toilet waste plus industrial wastewater. Coming to the wet weather flow, I told you that wet weather flow is nothing but the rain water or from roads and building roofs and other catchment area. That's nothing but the storm drainage. That is the wet weather flow. It is suitable for communities where there is short rainfall season with uniform rains. That is about the combined system. So there is advantages and disadvantages in combined system. First, advantages are it requires only one set of big size conduit. That means it is economical, but low operation and maintenance cost, large size sewer, stormwater provides automatic flushing of sewers. Okay, so the advantages are economical, low operation and maintenance cost. Okay, these things. Coming to the disadvantages of combined system, heavy hydraulic loading on wastewater treatment plant, unnecessary pollution of stormwater. These are the disadvantages of the combined system. Next, separate system. When the drainage and sewage are taken independently of each other through two different set of conduits is called a combined separate system. Here, combined means one taken along with one set of sewage. Separate system means independently two different set of conduits. Here, one large size of sewer, one large one. Here, there are two types of the conduits. That's the difference you need to understand here. One carries dry weather flow and another carries wet weather flow. But here, one pipe handles both dry weather flow and wet weather flow. Mostly preferred system, suitable for areas which receive heavy rainfall for long periods with non-uniform rain. This is a very important point here. Combined system will be having only one conduit handles both dry weather flow and wet weather flow. But in separate system, there are two conduits. It handles one is dry weather flow, other one is the wet weather flow. Okay. So these are the separate systems. Coming to the advantages of the separate system, only sewage discharge is treated and the drainage discharge is disposed of without any treatment. Less load on the wastewater treatment plant. No pollution of rainwater. Small size sewers which can be easily ventilated. Coming to the disadvantages, difficult to clean due to small size of sewer. Require two sets of conduits, make the system costly. Cannot be led in congested streets and locating more, making it physically unfeasible. So these are the disadvantages. But the thing is that separate system, it is advantages and economical to construct in the bigger cities and towns. So separate system is mainly in cities and towns. It is most economical and feasible. Okay. Next, coming to the third one, partially separate system. Sometimes a part of drainage water, especially that originating from the roofs, is allowed to into the sewers, and similarly sometimes the domestic sewage coming out from the residence is allowed to admit in the drains. The result system is called nothing but a partially separate system. Here, one thing is that one is from the rain roofs water, another one is the domestic sewage. Is nothing resulting system is called a partially separate system. It's suitable for areas which receives average rainfall with occasional heavy rains. So there are three types of wet systems. One is the combined system, another one is a separate system, third one is the partially separate system. So combined system, it is suitable for communities where there is a short rainfall season with uniform rains, whereas the separate system, it is suitable for heavy rainfall for long periods with non-uniform rains, and also most economical for the cities and towns. So this thing we need to keep in mind. Another one is the partially separate system. Partially separate system suitable for occasional heavy rainfalls. Okay, so there are three systems. These three systems you need to understand. Partially separate system is only for occasional heavy rains with average rainfall with occasional heavy rains. It is suitable. So in cities, separate system estimation of quantity of sewage discharge. That is nothing but the dry weather flow estimation of quantity of sewage discharge. Okay. I told you that dry weather flow, the flow of sanitary sewage alone in the absence of storms in dry season is nothing but the dry weather flow. Dry weather flow is nothing but the sullage plus toilet waste plus industrial wastewater except absence of storms. Okay. So here quantity of sewage. So quantity of sewage is nothing but the domestic sewage plus industrial sewage. So quantity of sewage is nothing but the domestic plus industrial sewage. This quantity of sewage is equal to the quantity of water supplied. Okay, but in actual practice, there will be a certain additions and subtractions do take place from it. Okay, so quantity of sewage is nothing but the domestic sewage plus industrial sewage, that is equal to the quantity of water supplied. So net quantity of sewage produced is equal to water supplied from water treatment plant plus additions minus subtractions. This is very important. Dry weather flow, nothing but estimation of quantity of sewage discharge. Quantity of sewage discharge is nothing but the domestic sewage plus industrial sewage. It is equal to the quantity of water supplied, and I have to consider additions and subtractions. So here additions means the private water supplies, and additions due to the infiltration like cracks and faulty joints depends on height of groundwater table above the sewer inlet, permeability of soil, size and nature of walls for high groundwater tables. Okay. Subtractions means due to water losses, leakage in the distribution system, due to water not entering the sewerage system, flow of wastewater from sewer into the ground. So these are the additions and subtractions. Additions due to infiltration and subtractions due to water losses and water leakages. Okay. In India, the quantity of sewage dry weather flow produced is taken as 70 to 80% of water supplied from the treatment plant. This is very important. In India, quantity of sewage dry weather flow is nothing but the 70 to 80% of accounted water supplied from water treatment. So this is about the dry weather flow. Next, coming to the next slide, variations of sewage flow. Generally, the maximum daily flow is considered as 2 into average daily flow. Maximum hourly flow is nothing but 1.5 into maximum daily flow or 3 into average daily flow. Okay. Generally, these peak flows for lateral sewers are much greater than that of large trunk sewers, because I told you that here lateral sewers, lateral sewers, lateral sewers which receives the discharge from house sewer. I told you here maximum daily flow is nothing but 2 into average daily flow. Maximum hourly flow is nothing but 1.5 into maximum daily flow or 3 into average daily flow. Peak flows for lateral sewers are much greater than large trunk sewers. Here lateral sewers means sewer receives the discharge from house sewer. Okay. So house sewer again it carries a sewage from a building to the point of its immediate disposal. Okay. So again trunk sewer. So trunk sewers carry sewage from branch sewers. Here for peak flows for lateral sewers are much greater than the large trunk sewers, because more flow time of for trunk sewers compared to the lateral. Sewers are designed for carrying the maximum hour flow running 3 by 4th full. These are very important. So sewers are designed for carrying the maximum hourly flow. Maximum hourly flow is nothing but the 3 into average daily flow. That designed for the running 3 by 4th full. Okay. Next, coming to the minimum flow. At minimum flow, velocity reduces, therefore silting occurs. Okay, at minimum flow, velocity reduces, therefore silting occurs. Slope at which sewer is to be laid is decided based on the permissible minimum velocity at minimum flow. Again, here minimum daily flow, minimum hourly flow. Minimum daily flow is nothing but 2 by 3 into average daily flow. Minimum hourly flow is 1 by 2 into minimum daily flow, or 1 by 3 into average daily flow. These are the very important. Maximum daily flow is 2 into average daily flow. Minimum daily flow is 2 by 3 into average daily flow. Minimum maximum hourly flow is 3 into average daily flow. This is 1 by 3 into average daily flow. Okay. Sewers must be checked for minimum velocities at their minimum hourly flow. Why means at minimum flow velocity reduces. Therefore, silting occurs. To avoid silting, we have to check for the minimum velocity. Now coming to the estimation of wet weather flow, storm water. Generally, this estimation of wet weather flow, storm water, uh, uh, nothing but the peak runoff. First, generally we have the two methods. One is the rational method, another one is the empirical method. Uh, in rational method, first we discuss about the rational method. Rational method is a modern method to estimate the peak drainage discharge. So rational formula. This rational method is used for catchment area less than or equal to 400 hectares. Understanding everyone here, this estimation of peak runoff by using the rational method. Rational method, it is a modern method used for catchment area less than or equal to 400 hectares. Okay. So the formula for the calculating the peak runoff is discharge of wet weather flow is equal to A into I into R by 360. Okay. Here the term A represents catchment area contributing to the runoff in hectares. Okay. 1 hectare is equal to 1 hectare is equal to square meters. Okay. So 10,000 square meters here, 1 hectare is equal to. Next term here, I is equal to coefficient of runoff or impermeable coefficient. So this coefficient of runoff I is equal to runoff runoff by rainfall. The term rainfall is also called as a precipitation. Okay, understanding everyone here, the coefficient of runoff is equal to runoff by rain. This coefficient of runoff, it depends upon the catchment surface type. Generally it depends upon the catchment surface type. Okay, next one is the R. Here R stands for rainfall intensity. Generally the rainfall intensity is expressed in millimeters per hour, corresponding to the time of concentration. Understanding everyone here, in rational method, the discharge of wet weather flow is equal to AIR by 360. Here A stands for catchment area contributing to the runoff. It is expressed in hectare. Another one is I, is nothing but the coefficient of runoff. Coefficient of runoff is equal to runoff by rainfall. Rainfall is nothing but the precipitation. Another one is the R. R is nothing but the rainfall intensity. It is expressed in millimeter per hour, corresponding to the time of concentration. Here, the term time of concentration is nothing but the period after which the entire area will start contributing to the runoff is called the time of concentration. The period which the entire area will start contributing to runoff after that. Generally, the time of concentration of a drainage basin may be defined as the time required by the runoff water to reach the outlet is nothing but the time of concentration. Coming to that, this coefficient of runoff I is also defined as impermeable coefficient. Okay, so understanding everyone here, so this is about the rational formula to calculate the discharge of wet weather flow. Okay, next we'll discuss about the empirical formulae. Generally, these empirical formulas used for catchment areas greater than 400 hectares, because based on this only it has been defined. Okay, so generally the developed by the investigators depending upon the actual experimental works. So these empirical formulae used for catchment area greater than 400 hectares. Okay, the first one is the Dickens formula. This formula is generally applicable for North Indian catchments. Okay, this Dickens formula is applicable for North Indian catchments. So discharge is equal to CD into A power 3 by 4 here. Here QP stands for peak drainage discharge in cubic meter per second. Okay. Here term CD is equal to Dickens constant depending upon 15 to 20 factors which affect runoff, like the nature of the catchment, intensity of rainfall, etc. Average value of CD equal to 11.5 is generally used, and it should be increased for hilly catchment and vice. Another one is the A. The term A is equal to catchment area in square kilometer. Okay. So understand here, Dickens formula is applicable the catchment area greater than 400 hectares, first thing, and second thing is that is applicable for North Indian only, North Indian catchments. For peak drainage discharge is equal to CD into A power 3 by 4. Here CD stands for Dickens constant. It is equal to 11.5. Generally it is used. A is nothing but the catchment area in square kilometers. Okay. Next, another one is the Reeves formula. Generally, this formula is generally applicable for South Indian catchments, whereas the Dickens formula is applicable for North Indian. The Reeves formula is applicable for South Indian catchments. Here, peak drainage discharge is equal to CR suffix into A power 2 by 3 here. QP stands for peak drainage discharge in meter cube per second, and CR is nothing but the Reeves constant depending on the factors which affect runoff. So the average value of CR, that Reeves constant, is 6.8, with a less value for flat catchments and more value for hilly catchment. Okay, A is the catchment area in square kilometers. So here we are having a two methods discussed about. One is the rational method, another one is the empirical method. In empirical method, we are again having two formulas. One is the Dickens formula, another one is the Reeves formula. This Dickens formula is applicable for the catchment area more than 400 hectares for North Indian, but Reeves formula is applicable for South Indian. In Dickens formula, the term Dickens constant is used here. Reeves constant is used. So QP is equal to CD into A power 3 by 4 for Dickens formula. For Reeves formula, QP is equal to CR into A power 2 by 3. In Dickens constant, his average value is 11.5. For Reeves constant, the average value is 6.8. So these formulas we need to understand more critically here. So you have to understand that this estimation of quantity of drainage discharge which is produced during monsoon season is generally very high, 20 to 25 times that of the sewage discharge. Okay, generally the partial separate sewers may be designed for carrying the sewage discharge plus part of the storm drainage, particularly that coming from the roofs and courtyards. The experts have recommended 2-year rain frequency for designing smaller link drains and 5 years frequency for designing all the major drains. So these all about the estimation of quantity of drainage discharge, that is nothing but the storm water flow. So, so let us see an example. Find the dry weather flow, that is the sewage flow produced by the community with a population of 1 lakh, supplied water at a rate of 200 LPCD. So LPCD stands for liter per capita per demand. Okay, liter per capita demand, and 80% of which become as sewage. The first thing is that you need to understand here dry weather flow. Okay, we need to calculate the dry weather flow here. In India, dry weather flow, that is quantity of sewage, is expressed as 70 to 80% of the water supplied by the water treatment plant. Okay, so first let us see here. Here the population is the 1 lakh at a rate of 200 LPCD, that's a per capita per demand, and 80% of which becomes as a sewage. Okay, so let us see the solution here. So the quantity of dry weather flow, that is nothing but the quantity of sewage is equal to population into per capita water supply into the factor here. Here the population is 1 lakh into the per capita water supply is 200, and then the factor, that's 80%, means 80 by 100 is equal to 0.8 cubic meter per second. Okay, The simple problem, the quantity of dry weather flow is equal to population into per capita water supply into factor. So this is about the introduction to the wastewater engineering. So let me revise the topics whatever we have discussed here. So first we discussed about the objectives of wastewater engineering. That is, there are three objectives majorly. One is protect the community from diseases and protect the environment, the like water bodies from human activities. And third thing is that drain off the wastewater from the community as quickly as possible. These three objectives, one is the protecting the community from diseases, protecting the environment from human activities, and draining off the wastewater from the community as quickly as possible. I told you that some terminology, sullage, first one, is nothing but the liquid wastewater produced by the community, like wastewater from bathroom, kitchen, and second one is the sewage. It is also liquid wastewater from the community, but thing is that it is somewhat foul in nature due to the presence of organic waste. Okay, and third one is the dry weather flow. Dry weather flow is nothing but sullage plus toilet waste plus industrial wastewater. And fourth one, drainage. Drainage means the runoff from building roofs and other catchment area is nothing but the drainage. Simply it is wet weather flow. Subsoil water, it indicates the groundwater which finds its entry into the sewer through leaks. Night soil, it indicates the human waste or excreta. Sewer means a pipe or a conduit carrying a sewage. Sewerage system means a network of sewer pipes carry the sewage from individual homes to the sewage treatment plant. Is called sewerage. And then we discussed about the components of a sewerage system, house sewer, lateral sewer, branch sewer, trunk sewer, outfall sewer, catch basins. We discussed about that, and then we discussed about the systems of sanitation. There are majorly two systems. One is the dry system and wet system. Again, we discussed about the types of wet systems. There are three types. One is the combined system, separate system. Another one is the partially separate system, and then we discussed about the estimation of quantity of sewage discharge, that is nothing but the dry weather flow. And then we discussed about the rational formulae and empirical formulae to calculate these dry weather flow. So these are all about the today's lecture, that is the wastewater engineering introduction. Okay, thank you.